In this video, we are going to talk about keys and relational database. First, let's talk about keys. Consider a table called Taiwan cities. This table contains one row for each Taiwan cities. Here are some sample rows. Now, we ask the question, which column of the Taiwan city table or which combination of the columns uniquely identifies a Taiwan city? Is it city code, city name? Is it the combination of city code and region? Is it something else? Well, a city code is an official abbreviation for a Taiwan city. Each city code officially designates exactly one Taiwan city in real life. Or to put it a different way, city code is a unique identifier for a Taiwan city. As an identifier, it has one very desirable characteristic: it is highly stable. Stability means that the value of the identifier aren't likely to change their meanings. TPE refers to Taipei City, and we can be confident we are not going to wake up tomorrow to find that TPE now refers to Tainan City instead. But some identifiers don't possess this level of stability. If we were trying to identify people using their mobile phone numbers, we could easily run into problems. A mobile phone number is not a stable identifier for a person because people can and quite often to change their phone numbers. With city code being a good, stable, unique identifier for a city, we are probably going to want to designate city code as the primary key of the Taiwan cities table. What this means in practice is that if a row currently exists in the Taiwan city table with city code KHH, and somebody tries to insert an additional row with city code KHH, then the insert will fail. By making city code the primary key, we are signaling that city code is going to be a 100% reliable shorthand for referring to a specific city. In other words, for referring to a specific row in the Taiwan cities table. It's also worth mentioning that city code can contain a null. The database platform doesn't permit you to have primary keys with nullable attributes in them. This makes sense, because to identify something you need an identifier value and null isn't a value. Now that the primary key is defined as city code, we can speak of the KHH row secure in the knowledge that there won't be any ambiguity about which row we mean. There will only ever be one. Our database might have other tables besides the Taiwan city table that also make reference to Taiwan cities. Perhaps we have a voters table that records information about which city a given voter is registered to vote in. Ideally, we want the codes in the city of voter registration column to be drawn from the same set of codes as the ones in the Taiwan cities table, because otherwise we won't be able to relate one to the other. What city is QXC supposed to represent? There isn't a QXC in the Taiwan cities table because there is no Taiwan cities with the abbreviation QXC. It's safe to say QXC shouldn't be allowed in the voters table. So how do we disallow it? The answer is we can set up what we can call a foreign key constraint. This constraint tells the database that the city of voter registration column is a foreign key to the city code column on the Taiwan cities table, which means that every value of city of voter registration in the voters table must match a value of city code in the Taiwan cities table. With this foreign key in place, city of voter registration can never be set to QXC because there is no QXC city code in the Taiwan city table. Foreign key constraints ensure that data in different tables hangs together. With city of voter registration set up as a foreign key to city code, we can reliably join the voters table to the Taiwan cities table using a query like this. Our join criterion is that the state from the voters table equals the state from the Taiwan city table. And because both of these cities are expressed using the same convention, namely as Taiwan city abbreviations like TPE and TNN, our join should give the desired results. We will talk about how to code the queries in next video. Next, we are going to dive a little bit into relational database. I'm going to get into some of the characteristics of the database model and also some benefits that it provides for you when making your decision that you want to use this for your next project to get started. Let's talk about the structure of the relational database system. It's going to pretty much match out your data points and bring out the relationship in that. And the way that it accomplishes that is through the first thing is making tables, which represents particular items or nouns or particular entities of your particular system that you want to actually prototype. So let's say I have a bunch of books. Now, this is going to be a table. It accomplished the attributes of this book by having columns and columns with being things like name, date, maybe author. Of course, got to have an author for a book, and every table is going to have an ID, field, some way to uniquely identify it, each row of this. Data table represents an actual record or an item, a type of book. That's how it really fulfills that ability to hold the database system there. And then as you wait, you kind of query out this particular system is through what we call a SQL, Structured Query Language. And it's a particular system you can say, select all the books and give me all this data out for me to use. Now we have one particular item here, books, but where it really comes, you really see the power of a relational database. Let's say now I want to show the authors and the way that relational databases can really provide the structure of relating these two entities together is by describing them through a particular entity or relationships. You have one that you're here about where books can have multiple authors, so maybe a one-to-many. You can have one-to-one. And just a couple of relationships you can kind of mirror within the database system. So one way what I can have this kind of a normalized structure is to say definitely the authors is going to have its own particular ID and name and any particular order of attributes that I want to describe there. But I can also, one of these fields can be an actual number that actually relates to the ID of this field. And this is what's known as foreign key. And of course, there will be a name there. So when I do my query, the next query I do, I can reference both these tables and say, hey, give me all the books and give me more of the author information from this table using this foreign key to describe that particular structure there. So this is all the characteristics of what you kind of have to model out your particular application that you want to build and describe how the entities are related to each other. Now, let's switch over here to some of the benefits that you're going to get out of the box with the relational database that you want to use. The first we'll talk about is actually consistency. Now, this is useful because let's say there is some point where I want to run multiple of these transactions. Let's say I'm modeling an inventory system for an e-commerce application, and I have the needs to write several queries in a row that may manage a couple of different subsystems. But if one of those queries fail, I want the option to be able to roll back the whole set of all those queries just to make sure that my data always maintains some consistency there. The second is the option to do stored procedures. Sounds like a very complicated word here, but think of stored procedures as the ability to write multiple blocks or functions of code. Or if there are a certain number of queries that I continue to always run, I can kind of model these. So it takes me less code to write that particular to access that same functionalities with less SQL code. And as you start to get into more SQL writing with relational database, your C queries can get pretty big. Another way you can do this, as well as another topic called views here. Definitely want to introduce some of these keywords as you do your deeper dive. You were able to see a lot of these and it be familiar to you. And the last one is a mechanism to handle locking in the database and concurrency. Why is that important? Well, at some point, multiple users are going to want to use the database maybe at the same time. Maybe two applications are going to be adding in books. And if the first application is making a particular insert into this table, you are going to want to make sure that the database is locked until that write is done, and then the second application has its ability to go in and make it insert as well. So there are all built into a lot of the relational databases that you use. A lot of these benefits will be provided for you out of the box. Not necessarily something you'll have to write in code, but just know that you have this at top of mind when you are kind of selecting to use a relational database for your next project. I hope this is good for you to understand the foundation of relational database. Thank you.